In our Chapter 2 mini unit, we're going to review a couple lessons that we learned in Chapter 2 and go over some things before we go into Chapter 3. So again, to review with some exponents, 3 to the 0 power equals 1. Anytime we have any number raised to the 0 power, it's going to be a 1. And if we want to rewrite 3 to the negative third with a positive exponent, we're going to write 1 over 3 to the third, which is equal to 1 over 3 times 3 times 3, which is 1 over 27. So again, anything raised to the 0 power is 1, and then anything with a negative power, we want to write it as a multiplicative inverse with this in the denominator. And then another note is any exponent that is not present for a given number or variable, it is a 1. So in the examples here where we just have the number 2, that equals 2 to the first power, or just plain 2, and x equals x to the first power. So whenever you see an exponent, whenever you see a variable, its exponent is 1 if it's not present. When we think about product of powers, to multiply powers with the same base, add the exponent. So for this example right here, we have 2 to the third power, which is 2 times 2 times 2, and then times 2 to the fourth power, which is times 2 times 2 times 2 times 2. Well, we know that multiplication is commutative, so we could just combine all of this to be 2 to the seventh power. So instead of writing it all out like this and then getting it back into an exponent, we can simply just add the exponents, so 2 to the 3 plus 4. And typically we'll see parentheses right here around the exponent, just so we don't confuse it. And that'll also equals 2 to the 7th power. And then when you evaluate, we get 128. And if we were to continue here with a couple examples, here 5 is our common base. So we're going to go 5 to the 4 plus 2 power. And that'll give us 5 to the 6th power, and that's our final answer. Because look at our directions, they want positive exponents, so as long as we have a positive exponent, we're okay. 4 is the common base, we're going to go 4 to the 4 plus 0 plus negative 2, and so 4 plus 0 is 4, plus negative 2, so if I have 4 and I owe 2, I'm going to have 2, so 4 to the 2nd power, and that is a positive exponent, so I know that I'm good with that. Moving on here, 5 is the common base, so 5 to the 4 plus negative 1. And so if I have 4 and I owe 1, I'm going to have 3, so 5 to the 3rd power. Again, the directions say that I want positive exponents, so as long as I have positive exponents, I am done. So here, common base is 4. Notice I'm not actually multiplying the 4's together. I'm just working with their variables. If the variables were all 1s, then we could go ahead and multiply the numbers. But here, we're just going to manipulate and work with the variables, or the exponents. So 4 to the 3 plus negative 5 plus 0. So if I have 3 and I owe 5 and I have 0, it means I have 4 as my base and I owe 2. Okay, now this is not a positive exponent. So I want to rewrite that as 1 over 4 squared. And that's actually going to be my answer. I don't have to go any further than that because answers should contain only positive exponents are my directions. Now with example 5 and 6, we get a little bit more sophisticated here in that we're actually adding coefficients with our variables that have exponents. So first thing I'm going to do here is I'm going to notice that I have 1, 2, 3 negatives in this problem. So I know my answer in the end is going to be negative because that's an odd number. Now the coefficient here is 1, so 1 times 5. See, now I am multiplying my numbers because the exponent is just a 1. So I can just go ahead and do 5 times 4, which is 20. And then I'm going to look at all of my same base variables. So I have x to the 3rd plus negative 3rd plus negative 4th. And then my positive 3 and negative 3 will cancel, so I'm going to have 20 times x to the negative fourth. But that's not a positive exponent, so I want to rewrite that again, 20 over x to the fourth. Now, if you remember, I have this negative sign circled because I know that my answer needed to be negative. So this whole thing is going to be negative. So again, looking at where we got all these numbers. Well, I got the negative sign because I have 3 negatives. So 3 negatives is always going to be negative. I got the 20 from 5 times 4, and this is a 1. So 1 times 5 times 4 is 20. And x to the fourth on the denominator. Well, I got that from adding 3 plus negative 3, which is 0, plus negative 4. So I had negative 4, and I know I don't want a negative exponent. So to make this part here a positive exponent, I have to put it in the denominator. So that's how I got negative 20 divided by x to the fourth. So looking at the example 6, I see I have one negative right there, so I know my answer is going to be negative. I'll just write a note to myself. Now I can do 1 times 5, which is 5. And then I have n, and there's a 4 plus a 3. So I'm getting the 4 here and the 3 here. So when I rewrite it, 5 times n to the 7th, and I knew it was going to be negative, so I'll just add my negative in right here. And since my exponent is positive, I don't need to do anything else to the number. Okay, so example 7. Again, first thing I'm going to do is I'm going to look at my negative signs. So since I have 2 negatives, I know my answer is going to be positive. I'm just making a little note down here. Now I can do 3 times 4, which is 12. And I have an r here and an r here. So r to the fourth plus, now whenever there's no exponent, I know that it's a 1. So I got to add that 1 also. So I have 12r to the fifth power. And since it was going to be positive, I know I'm going to be done right now because my exponent is also positive. Example 8, I have a negative and a negative, so I know my answer is going to be positive. And then I'm going to do 4 times 4. Notice I don't have any exponents here, so that's why I can just go ahead and multiply 4 times 4 because the commutative property allows me to do those. So I have 16 times x to the 4 plus 2. So when I rewrite it, it's going to be 16x to the 6th power. And I knew it was going to be positive. So I am done. And since I have a positive exponent, I don't need to do anything else. So be sure to check out these examples here in your notes. Also, I have the answer key for the assignment posted on Moodle as well. So take a look at those 2 options to get you started with today's lesson.